Hi everyone, welcome to Javaras. Let's continue our discussion on securing single page applications using Spring Security. So far, we have created a front-end server Angular app and a resource server. Front-end server is responsible for serving Angular app. As you can see here, this is the front-end server and it builds and serves the Angular app. It is also responsible for authentication. So we can log in using Angular app and we can access secured resources from front-end server. In the last video, we have created a resource server and we have added Spring Security to it. We have created a dummy endpoint slash demo slash hello in resource server. And since we want to access this endpoint from Angular app, which is on different origin, which is 8081, and resource server will be on different origin 8082. That's why we need to add cross origin annotation here so that this endpoint can be accessed from this origin. If you have not watched the previous video, please do that first. I will put the link to playlist and previous video in the description. Also, you can find the code in this GitHub repository. You can go to specific branch to see the code related to that video only. I will put the link to this repository in the description. Now in this video, we are going to understand cross-origin resource sharing or CORS in a little bit more detail. Also, we will add some more CORS configuration resource server to allow requests from Angular endpoint. If you want to understand CORS in more detail, you can go to this website. I will put the link in the description. Now this is our app and we have a button here say hello. After clicking on which we send a request to resource server here localhost 8082 demo hello, which means this endpoint, and then we alert whatever we get back. Let's click on this button. Now we see two requests here. First is options, second is get. So this is the original request which we want to send to the resource server, get request. And since the origin is different, so browser will send another request which is called pre-flight request, which you can see here. So now if you see in the original request, we are sending some request headers. Most of the request headers are common request headers, which are considered as safe request headers. And there is one request header which is X requested with, which is not a common request header. And those are considered unsafe request headers. So pre-flight request, what it does is, if you see in the request header of pre-flight request, there are some headers, access control request headers. So this header tells the resource server that which request header will be sent in the original request, and that is X requested with. And if you see in the second header, which is access control request method, this tells us that what will be the request method of the original request, which is get. And it also sends the origin, that from where the request will come. And now it's responsibility of the resource server to tell browser whether the original request with these request header, request method and origin should be allowed or not. But we are not getting this information right now. Right now we are getting error in the response, a 401 error, because we are using Spring Security in resource server, and by default it will authenticate all the request. So it will authenticate pre-flight request as well. But we don't want that. We want all the pre-flight requests to bypass the Spring Security. For that we need to have a configuration. It's a very small configuration. Let's do that. I will create a new Java class called security configuration, and I want to create this class inside a package called configuration. Now let's annotate this with configuration. And we have already seen how to define security configuration in Spring Security. Create a method which will return security filter chain. We can give it any name. It will accept HTTP security as parameter, and at the end it will return http dot build. And let's add a exception here, and let's make it a bean, so don't forget to annotate it with bean. Now here we can configure the HTTP security. Let's say HTTP dot authorize HTTP requests, auth z auth z dot, let's say any request. We want to authenticate all the requests. I will do this, and let's authenticate using HTTP basic and with default configuration. So that's it. Now we need to tell Spring Security to bypass all the pre-flight requests. For that, just add CORS here and with default. So just by adding this CORS here, we all the pre-flight requests will bypass Spring Security. Now let's rerun the resource server. You can run using command line with this command /gradlw boot run. Yeah, so it has started. Now let's click on say hello button again. This is the response for pre-flight request. In the request headers, we are sending access control request header x requested with. That means original request will have this request header. This will be the method of original request, and this will be the origin. In the response header, we are getting back this access control allow headers. That means this header is allowed. This method is allowed, and this origin is allowed. That means our request is allowed. But in the request, we are getting 401. This is authenticated on the front end server, but there is no way to communicate between a front end server and resource server whether the user is authenticated or not. So for resource server, the current user is not authenticated. That's why we are getting 401. We will fix that in the next video. But in this video, let's continue focusing on CORS. So to demonstrate the CORS, what I will do is I will add one configuration. So whenever I uh, get any request to demo hello, I want to permit it. I don't want to authenticate it. I rerun it, click on say hello again, and we can see we are getting hello word in the response. Let's go to demo controller. Now in the cross origin, you can configure many other things as well, like what request headers should be allowed. Let's say allowed headers. By default, all headers are allowed, but we don't want to do that. We want to allow some headers. For example, currently we are sending this header, this custom header, X requested with. So let's disallow it. So in the allowed headers, I will say something else like X ABC. Now only this custom header will be allowed. All others headers will be disallowed. So save it and I will run it again. Now click on say hello again. Okay. Now we get something here. So if you click on options and here in the request header we are sending access control request header X requested with. That means original request will have this header, but in the response header we are not getting that. That means we are not allowed to send this header X requested with. Now let's add this header as well here. X X requested with, and then restart the app. Let's click on say hello again. Now we can see it is allowed. Let's go to get options here. So we are checking for X requested with, and it is allowed. Now one thing to note here is that in the access control allow headers we are only getting X requested with, but here we have defined X ABC as well. So it's not necessary that server will give you all the information. Server will give you the information which is required. You don't require the information whether the X ABC header is allowed or not, so it won't give you that information. It will only give you the information which is required, and we can test that in the if you go to like app.component.ts, or let's go to uh, that interceptor which we have created, XHR interceptor. Now here with this let's add one more header. Let's set X, A, B, C, and its value, let's say DF. Now two headers will be sent. I will save it and then restart the front-end server. So it will rebuild the Angular app. The server has started. Let's go to the Angular app again. Log in here. And let's click on say hello button again. You can see hello world. Let's look at the original request. In the original request, we are sending two request headers X ABC and X requested with. You see in the replied request, you can see accept control request headers. There are two headers X ABC and X requested with. And in the response headers of pre-flight request, access control allow headers, we see X ABC and X requested with. That means the resource server will only send the information which is required. It won't send any additional information. So that's how the cross origin resource sharing mechanism works. If you want to know about it in more details, you can go to this documentation. So this is a very great documentation. So you should definitely check it out. And in the next video, we will fix the problem of getting 401 error. So like when we remove this thing and restart the server, click on say hello and we are getting 401. The authentication state from the front end server is not accessible to resource server. In the next video, we will fix this problem. That's it for this video. Thanks for watching.